Hello, I'm Sean Lamp with Danfoss Drives North American Service Department. Today I'm going to go over how to analyze the data captured by NXS and NXP drives when they have a fault.
Please take a moment now to read the safety warnings shown here. Failure to follow these warnings could result in death or serious injury.
In this example that we're looking at here, we're going to take a look at the service information file printed from the drive. So we're going to go down and take a look and see what faults we're trying to troubleshoot here. And certainly looks like we're looking at overcurrent faults. So just taking a quick look at the data that we captured, that we see that right now when it was printed, it was that we were at 3 years, 117 days. And our last fault was at 3 years, 117 days. So basically the fault was roughly about 9 hours before we actually printed the file. Output frequency was at 39.86 hertz. Motor current was at 1 amp. Again, we're looking at virtually you can have a current trip at 1 amp on a drive, but we'll take a look and see what size drive we're dealing with. This one here says it is a 920 amp drive at 500 volts. So a 920 amp drive, I said 1 amp, we're not gonna trip. Motor voltage 302 volts, 14% power, 21% torque. So we don't know whether that's correct or not, but certainly doesn't look like we're putting out much power if that's correct. We were ready. We were running. Our direction was forward, not at fault, not at warning. We were at reference. DC bus was 713 volts. Unit temperature 43 degrees Celsius. Our subcode was S1, which on an overcurrent fault, subcode S1 is a hardware overcurrent fault. This was a star coupled drive, so there's 2 power sections, so it does tell us which power section it is. It's in power section 2. And it thinks it's in the U phase. And we just go back and see if, these kind of match going down. Again, our current is low there, but, about the, roughly speaking, the same power and torque, same DC bus. A little bit warmer for temperature, but we do have the hardware overcurrent trip in power unit 2, U phase, so that agrees. Here we actually captured some current that we do have 234 amps. I said that's getting a little bit more realistic, although that's way lower than what current trip would be on this size drive, being a 920 amp drive. The CT rating is 820 amps, so you'd be dealing with about 2500 amps. So looking through these kind of match going down here, you can see we got a bit more current, but it's still about pretty low in power. I said we got a little bit more torque involved there. DC bus has been pretty consistent at about 715 volts. And we have been consistent with power unit 2 U phase. So let's take a look at the data log itself and see if we can see what's happening. So here's the data log from that. Again, it's a little bit hard to read the way it is, so we're going to, this is where it tripped right here. So we're going to box this area out, expand that data. We want to maybe get that a little bit more. So we'll stretch that out a little bit. We'll grab our measuring bar and bring it across here. So right about here is where it tripped, but right in this area is where things went wrong. So that's where we're probably going to want to look and see what happened there. So as we look right here, you can see our U phase current is at about 150%, whereas we don't have anything on the V or W phase current. We know that that's not all that possible unless everything went to ground. And we don't see any real jump in DC bus here. It's a DC bus stays pretty consistent. That we went from 711 to 722, so there's just a 10 volt difference, which is probably just a difference of the drive turning off. So let's get rid of some of these other signals in here so that we can just kind of look at the the current signals and the voltage signals. So let's turn them off. So we'll turn torque off. We'll turn our current off, regulator status, frequency output. So now we just got the three-phase currents in DC bus. So you can see before it tripped, everything looked good. You know, all of our currents were basically adding up as we go through any place in there, so that it looks like we aren't getting any ground current or anything like that. So that all looks good. DC bus is nice and stable as we're going through it. Here's where it starts to go wrong, that we're starting to get things uneven, but then this really spikes right about here. And where it spikes, I said that because we aren't looking at any jump in DC bus or anything like that, it's really high. What we're going to figure is that this is probably a false current here, that this is some feedback that's spiking when it shouldn't spike. And on here, we can't tell. This has got two power sections. We can't really tell which power section it is, but if we go back to the fault histories, this is telling us that it's in power section 2. And it thinks it's U phase, which we kind of confirm that it is U phase. By this, it is U phase that did spike. So looking at this, we'd say this really couldn't, not that it's impossible to happen in the real world, but it's very unlikely for this to happen in the real world, that this is a false current feedback. Especially considering that DC bus didn't do anything. If we drew that much current, 150%, we should have seen DC bus at least drop a little bit. So we're going to say that this is probably false current in power section 2. The most likely thing to cause that in an NX drive would be the current measurement boards. So in this one, we'd say, yeah, it's probably a current measurement board. We can't guarantee it's a current measurement board, but it's probably the current measurement board in power section 2. So probably the first thing we would do is swap the current measurement boards in power section 2.
Thank you for viewing. We hope this information has been helpful. Danfoss Drives can provide additional technical support, parts information or repair services options by contacting us through one of the following methods. For immediate access to customer service or a technical support expert in North America, call 1-888-DANFOSS, or 1-888-326-3677, or contact us by using one of the listed email addresses. Additional information is also available on our website at www.danfossdrives.com. For contact information in areas outside of North America, please visit our global website at www.danfoss.com.